So now that we've seen what this number e is, let's talk a little bit about how we use it. And the simple answer is we use it exactly the same way we use any other number. One way we use it is as a base of an exponential growth function. So y equals e to the x. Remember, e is just a number, 2.71828. So e to the x would behave just like any other number to the x, 2 to the x, 3 to the x. It would be exponential growth that has that horizontal asymptote at y equals 0, and then the growth, and then it just turns up and gets very steep. That is e to the x. It has the same domain as 2 to the x or 3 to the x, all real numbers, because you can plug any variable into an exponent. It has the same range as all of those exponential functions. If you start with a number like e and raise it to a power, it can get infinitely small, but it can't become 0. And then it can become infinitely big. So the range will be from 0 to infinity. The y-intercept is at 1. Sorry, 0, 1. I wrote that backwards because it's a y-intercept. And the end behavior is the same as the end behavior for our other exponential functions. As x approaches infinity, f of x, or you could say e to the x, also approaches infinity. And on the left-hand side, as x approaches negative infinity, f of x approaches 0. Well, if we use e, this new number, as the base of an exponential function, it won't shock you to learn that we also use it as the base of a logarithmic function. So we can graph the inverse of this guy, of e to the x, is the log base e of x. Those are inverses of each other. But we don't call it log base e. It has a different name. It's called the natural log. Right? E is called the natural base, and its log is called the natural log. And we have a different symbol for it. It's the letter L and the letter N of x. Ln of x. And so that's when we say it out loud, it sounds like we're saying the two letters, Ln. We don't call it ln. If you want to read it as the natural log of x, you can, but most people read it as Ln of x. If you call it log base e of x, you're not wrong. It's just that there's another name for it. And it's going to look just like any other logarithmic function. We'll have the vertical asymptote here, the x-intercept at 1, and then the really slow growth after that. So the domain would be everything from 0 to infinity. The range would be anything at all. Don't need parentheses there. All real numbers. If you wanted to write that as from negative infinity to infinity, you could. The intercept, this time it's not a y-intercept because ln of x never touches the y-axis. It is an x-intercept at 1, 0. And the end behavior for this one, it's the inverse of the old one. So as x approaches infinity, f of x, sorry, we're not talking about f of x anymore, g of x approaches infinity also. I took these two and I switched them around, but they're both infinity, so switching them doesn't really do anything. And on the other side, as x approaches 0, g of x approaches negative infinity. This time, taking these two and switching them actually does make a difference. Something else we do, now that we're talking about logs and exponentials, when we're dealing with the natural log and the natural base, we can rework our exponential equations as logs, or vice versa. And so this is a scale. I don't highlight this too much, but it is good to remember that we can do this if we want to. E to the x equals 8, we can rewrite that as a log if we want. Log base e, which we'll call the natural log, of 8 equals x. Natural log of 8 equals x. It doesn't matter which side the x is on. It's not like the x always has to be inside the log. I'm just taking an equation and reworking it. Or e to the fifth equals x means log base e of x. So ln of x is equal to 5. We can do that for logs also. ln of 10 means log base e of 10 equals x. So that means exponential with a base of e. So e to the x is equal to 10. Or e to the 2.1438 is equal to x.